In this video, we'll discuss precipitation reactions. Precipitation reactions are the result of two aqueous solutions being mixed when a precipitate is formed. A precipitate is a solid product from two aqueous solutions. So if you look at this example, you have two aqueous solutions, they're being mixed. All of a sudden, a yellow solid is formed. We call that the precipitate. And when we write our chemical equations, we would label the precipitate as solid because it's insoluble. And then we label the aqueous solutions as AQ because those are soluble. When you have a solid ionic compound and you add it to water, sometimes it can be aqueous, but sometimes it won't dissolve at all. And so we can use our solubility rules to determine whether or not that'll be aqueous. So sodium chloride, we have to look at the ions that make up sodium chloride. And you can see on the chart we have ions in different sections, and then it'll state whether or not those ions are soluble in water. And then there would be exceptions. So with this category right here, all of these are soluble with no exception. So no matter what, these are soluble. And notice that you have sodium in this section, right? So sodium, no matter what, is soluble. In this section, you have another set that are soluble, but if they're bonded to silver, mercury, or lead, guess what? That's an exception, so it would be the opposite. Instead of being soluble, it would be insoluble. And look, we have chloride, and so there's chloride right here. So sodium chloride is soluble, which means if you take solid sodium chloride, add it to water, it will dissolve and dissociate into its ions. So the formula, or the equation rather, would be solid sodium chloride mixed with water yields aqueous sodium ions plus aqueous chloride ions. So let's look at another one, calcium carbonate. We see there is no calcium on this chart, but we do have carbonate. Carbonate is insoluble. So carbonate is insoluble. When mixed with water, nothing happens. So you have solid calcium carbonate mixed with water yields solid calcium carbonate. Or you could write NR for no reaction. How about a molecular compound? Carbon monoxide, for example. Carbon monoxide is molecular, which means there are no ions. You have no ions, so you cannot use this chart. A big X. You can't use this chart. So what that gives you is, instead of dissociating, because we know substances like sugar, for example, can dissolve. So this would dissolve because we know that carbon monoxide is polar. And since it's polar, it'll dissolve. And so what you have is carbon monoxide mixed with water yields carbon monoxide. How about predicting products? So if we have a reaction that could potentially be a precipitation reaction, we can predict the products by using our solubility rules. Potassium sulfide with copper 2 chloride, they're both aqueous, so this looks like a double replacement reaction. We have our solubility rules. We will look at the result of the double replacement reaction to determine whether or not we have a precipitate. So we have potassium sulfide plus copper 2 chloride, and we have our potassium and our chloride. Those would potentially bond, but we can see over here that potassium and chloride are both soluble, so that's why we have an aqueous product. How about copper and sulfide? Copper is not on the chart, but sulfide is, and it is insoluble. So copper 2 sulfide is solid because sulfide is insoluble. So this is the precipitate. Now this thing is called a molecular equation, but it's not entirely accurate. We like to use the complete ionic equation to represent the aqueous nature of three of these different substances. So if it's aqueous, potassium sulfide and copper 2 chloride would be ions. So potassium, sulfide, copper, chloride are all ions, so this is a more accurate representation of what you have in solution. And then Potassium chloride is also aqueous, so this is more accurate. But notice that the copper 2 sulfide is unchanged because this is a solid product. This is a precipitate, so this is how you would write a precipitate in a balanced equation. So how about another version of this? We have this thing called a net ionic equation, which only shows the ions involved with the reaction. So instead of including all the ions, we only include copper and sulfide. So sulfide plus copper yields solid copper 2 sulfide. Okay, hopefully that helps.